All right, so today we did some enrichment on unit cells. And these are the problems that we did. So you can download this file from the course website, or you can just pause the recording, try it for yourself, and then resume when you're ready. So here are problems 1 through 4 for you to try. And then there's number 5. All right, so now, and again, this file is available on the course website. So now we're going to go over these. Oops. So now we're going to go over each one of these to make sure everybody knows how to do it. Because as I mentioned in lecture, you will be seeing this on the final. All right, so number 1, we're told that it's body-centered cubic. Right, so that's BCC. And we've got the edge length, so that's A, right? 3.011 angstroms. And we're told that it's vanadium, so you can look up its molar mass, which I got to be 50.942 grams per mole. And we want to know the density. All right, so density has the formula mass over volume, right? So we need to calculate mass of the cell, we need to calculate volume of the cell, correct? And then once we know those two values, we can just divide and get the density. So the first thing we want to do is we want to calculate, let's do the mass part first. Let's calculate mass of an atom. And what's the formula to get mass of an atom? How do you do that? Mass of an atom is equal to molar mass, grams per mole, divided by what? Avogadro number, right. 6.022 times 10 to the 23rd atoms per mole. All right, so those cancel. So that gives you grams per atom. So I got 8.459, you don't have to worry about sig figs really here, times 10 to the negative 23rd grams. That's the mass of one atom. That's what I came up with. But we don't want mass of an atom, we want M cell, right? Divided by V cell. So how will we get mass of a cell? Oop, not V yet, we're not there yet. M cell. If this is the mass of one atom, how do we get the mass of the entire cell? We're going to have to multiply by something. What are we going to multiply by? We're multiplying by 2. Right. Why? Because it's the mass of the atom times the number of atoms in cell. Right? And if we remember, simple cubic is 1, body center cubic is 2, and face center cubic is 4, right? So we're going to take this number, 8.459 times 10 to the negative 23rd grams, and multiply it by 2, and that gives us the net number of atoms, and that gives us the mass of the cell. And so when I did that, I got 1.692 times 10 to the negative 22nd grams. Now we need V cell. And how do you calculate the volume of a cell? If it's a cube, what's the volume of a cube? Length times width times height, right? And they're all the same in a cube. So that's A cubed. Now we've got the edge length A, but we don't want it to be in angstroms. Why? What unit does the volume need to be in? Centimeters cubed, right? Because centimeters cubed is the same thing as a milliliter. That's a unit of volume that we're familiar with. So we need to convert angstroms to centimeters, right? So 3.011 angstroms. How many angstroms are in a meter? 10 to the 10th angstroms per 1 meter. And then there are 100 centimeters per meter. So that gives me 3.011 times 10 to the negative 8 centimeters. Right? Angstroms cancel, meters cancel. So now I've got my edge length in centimeters. All I need to do is cube it. So 3.011 times 10 to the negative 8 centimeters. And we want to cube that. And I got 2.729 times 10 to the negative 23rd centimeters cubed. A centimeter cubed is the same thing as a milliliter, right? So you could write that as milliliters if you wanted. Now we know the mass of the cell, we know the volume of the cell, so we can calculate density. So density is mass of the cell divided by the volume of the cell. So 1.692 times 10 to the negative 22nd grams divided by 2.729 times 10 to the negative 23rd milliliters. Okay, I got 6.19 grams per mil. What did you come up with? Something similar? I hope. Questions on how we did number 1? All right, let's look at number 2. Go ahead and move it up, and then I'll erase. And let's do the page break. All right, this time we're dealing with krypton. It's face-centered cubic, we're told. And again, we're going to calculate density. So we're going to use the same procedure, right? We're going to use the exact same procedure. But this time it's face-centered cubic. And we've got edge length in picometers. So I look up the molar mass of krypton. Its molar mass I got to be 83.798 grams per mole. Face-centered cubic, so that means there are 4 atoms per cell, right? Edge length of 559 picometers. Let's go ahead and convert that to centimeters. How many picometers are in a meter? 10 to the 12th, right? And then 100 centimeters per meter. So picometers cancel, meters cancel. That gives me 5.59 times 10 to the negative 8 centimeters. Now I've got all my conversions done. All right, so I'm ready to go. So if density is M cell divided by V cell, let's calculate M cell. But first we need to get M atom. Right? Because we don't know, we can't calculate mass of the cell until we know the mass of an individual atom, right? So mass of an atom is what again? It's this divided by 83.798 divided by Avogadro's number. Because if this is grams per mole and this is atoms per mole, you get the mass of a single atom. So I got 1.392 times 10 to the negative 22nd. Now we can get the mass of the entire cell. Right? M cell is mass of an atom times number atoms in cell. So that would be 1.392 times 10 to the negative 22nd times 4, right? When I did that, I got 5.566 times 10 to the negative 22nd grams. Now we can calculate V cell. We've already got edge length in centimeters, right? Which is what we want it to be in. So we take our edge length and we're just going to cube it. So 5.59 times 10 to the negative 8th centimeters. And now we cube that. So I got 1.747 times 10 to the negative 22nd centimeters cubed, which is the same thing as a milliliter. And so now I'm ready to calculate density. M cell over V cell. So this divided by this. So 5.566 times 10 to the negative 22nd grams divided by 1.747 times 10 to the negative 22nd centimeters cubed. So I got 3.2. And I probably should carry out an extra decimal place there, but I didn't because I was bad at rounding. What'd you get for your second decimal place here? Because we should probably keep 3 sig figs since we have 3 sig figs here. 3.2, what was your second decimal place? 3.19, okay. Grams per centimeter cubed. Since we have 3 sig figs there, we should keep 3 sig figs there. You feeling good about doing density problems? Great. All right. Let's look at number 3. Okay, this time we're given edge length and density, and we want to know unit cell type. So we're going to work a little bit differently, right? But it's not going to be a whole lot more challenging than the previous ones. We just have different steps we need to follow. All right, so let's go ahead and convert all our units to meters just to be consistent. Converting to meters. But you could convert it to whatever unit you want. You just need to be consistent, right? Because this one's centimeters, this one's picometers. So just pick a unit, convert everybody to it. I just picked meters. So if our density is 3.180 grams per centimeter cubed, to convert that to meters, there are 100 centimeters in a meter, but this is cubed, so we need to cube it. So we're taking 100 and cubing it, multiplying it by 3.18. So that's 3.180 times 10 to the 6th grams per meter cubed. And let's also go ahead and convert our picometers to meters, right? 546.26 picometers. There are 10 to the 12th picometers per meter. So that gives me 5.4626 times 10 to the negative 10th meters. So again, you could have converted everybody to a different unit, just make sure that you're consistent. All right, let's calculate volume of the cell. V cell, so that's what? It's still just A cubed. And we just solved for A right here. So to get volume of the cell, we're just going to cube that. 5.4626 times 10 to the negative 10th meters. And let's cube it. So I got 1.63 times 10 to the negative 28 meters cubed. Now let's calculate the mass of the cell. How do we get the mass of the cell? What do we do to get mass of the cell? Well, we've got density given to us, so we could go the molar mass route. That'd be extra steps, but then we'd be in trouble because we don't know the cell type, right? So what would we do to get mass of the cell? Density times volume, right? If density is mass over volume, then mass is density times volume, right? So the density we've got right here in grams per meter cubed, so that's 3.180 times 10 to the 6th grams per meter cubed times, our answer is in meters cubed, so they'll cancel out, 1.63 times 10 to the negative 28 meters cubed. So this gives me the mass of a cell, which I got to be 5.184 times 10 to the negative 22nd grams. Now that's the mass of a cell. To get unit cell type, we need to figure out the mass of an atom, right? And then figure out how many atoms fit inside one cell. So how would we get the mass of the atom? Molar mass divided by Avogadro's number, right? Molar mass over Avogadro's number. So the molar mass is 78.08 grams per mole divided by 6.022 times 10 to the 23rd atoms per mole. So the mass of an individual atom I got to be 1.296 times 10 to the negative 22nd grams. And last step, we know the mass of the entire cell. We know the mass of an individual atom. So now we just need to figure out how many atoms fit inside one of these cells, right? So we're just going to divide these two. So cell type, or number of atoms in cell, would just be 5.184 times 10 to the negative 22nd divided by this. We're seeing how many of these fit into one of these. 1.296 times 10 to the negative 22nd. So that comes out to be 4. So since there are 4 atoms in the cell, what cell type can we conclude it is? It's space-centered cubic. Good. Do we have any questions on number 3? Are we good on 3? All right, let's look at 4. Whoa, got away. All right, number 4. So we're told that this metal is body-centered cubic. We know its density, and we know that the radius is 140 picometers. We want to know molar mass. So, first thing that I jump out and see is we're given a radius. Does radius help me really at all in my calculations? I'm going to go ahead and convert that into what? Because I need to convert it into edge length, right? And because this is BCC, I can look at my list of relationships. Wherever it is, there it is. Right? And I can look at my relationships and say, okay, BCC, there's the radius times 4 divided by square root of 3. That gives me edge length. So let's go ahead and convert that radius into an edge length. All right, so A is equal to 4r over the square root of 3. So that's 4 times 140 divided by square root of 3, which I got 323, and my unit would be picometers. And now, let's go ahead and convert that into centimeters. Why do we want that to be in centimeters? Because we're eventually going to be calculating what? We're going to be using density, right? So we need a volume. If we are going to eventually be needing V cell, that means we need the volume in milliliters, right? Because this is in milliliters, so that I can eventually get mass. So let's convert picometers to meters. 10 to the 12 picometers per meter times 100 centimeters per meter. Right, so I got 3.23 times 10 to the negative 8 centimeters. So now let's calculate V cell. Since this is a cube, it's just going to be edge length cubed. So that's 3.23 times 10 to the negative 8 centimeters. I'm just going to cube it. So I got 3.38 times 10 to the negative 23rd centimeters cubed, which is the same thing as a milliliter. All right, now I want mass of the cell. I've got the density, I've got the volume, so can I get the mass of the cell? Yeah. That would just be V cell times density, right? So this value, and remember, that's the same thing, 3.38 times 10 to the negative 23rd mils, right? Centimeter cubed and milliliters are the same. So 3.38 times 10 to the negative 23rd milliliters times the density that I was given in my problem up here, right? 10.5 grams per mil. So I got 3.55 times 10 to the negative 22nd grams. But that's not what I'm ultimately going for. I ultimately need the mass of a single atom. Why do I need to go all the way down to mass of an atom? Because remember, mass of an atom is equal to molar mass over Avogadro's number. If I know this and I know this, this is what I'm solving for, right? So that's why I have to go all the way down to mass of an atom. So we want mass of the atom. And how do we convert mass of the cell into mass of an atom? It's body center cubic, right? So what does that mean? There are 2 atoms in that cell, right? So I need to take this number and do what to it? Right, it's the mass of the cell divided by number of atoms in cell. So that's this number that we just obtained, 3.55 times 10 to the negative 22nd grams. And since it's body center cubic, that means there are 2 atoms in the cell. So when you divide that by 2, I got 1.774 times 10 to the negative 22nd grams. And now we just use this relationship. If I know the mass of an atom, which I do, and Avogadro's number is a constant, then I can solve for molar mass, right? So 1.774 times 10 to the negative 22nd is equal to x over 6.022 times 10 to the 23rd. I got x equals 106.85 grams per mole. So looking at the periodic table, that is most likely palladium. Do we agree? Did you get the same answer? Now your answer might vary number of decimal places like your sig figs based on number of decimals that you carry up here. How do we feel about number 4? Feeling all right? All right, last one. Another molar mass calculation. So this time, we're told that it is face-centered cubic. We're given the density, and we're asked for the molar mass and the identity. This time we've given edge length, so we don't need to worry about converting a radius into an edge length because it's already in an edge length. We just want to convert that edge length into what unit? Centimeters, right? Because remember, our ultimate goal, if mass of an atom is molar mass over Avogadro's number, right? We want to eventually get mass of an atom. So that means we need to turn this into centimeters. So we can turn it into a volume, which we can multiply by the density to get mass of the cell, which then we can get mass of the atom. So it's a lot of steps, right? But it's not horrifically difficult math. That's the good news. So 4.06 angstroms times 10 to the 10th angstroms per meter times 100 centimeters per meter gives me 4.06 times 10 to the negative 8 centimeters. And that's A, right? So now we want volume of the cell. So we're going to take that. And we're going to cube it. So I got 6.692 times 10 to the negative 23rd milliliters, right? Because centimeters cubed and milliliters are the same thing. Now I want mass of the entire cell. So that would be the density times the volume, right? Oops, not density equals, density times volume. So 11.5 grams per mil times 6.692 times 10 to the negative 23rd mils. So that's 7.696 times 10 to the negative 22nd grams. Now we want mass of the atom, right? Because ultimately that's what we're going for here, so we can plug in for molar mass. So mass of an individual atom would be mass of the cell divided by number of atoms in cell. So that would be this number, 7.696 times 10 to the negative 22nd grams. How many atoms are in a face-centered cubic unit cell? 4, right, so we're dividing by 4. So when I do that, I got 1.924 times 10 to the negative 22nd grams. All right, so now we're just plugging into this relationship, right? If mass of an atom is equal to molar mass over Avogadro's number, and this is a constant, and we just solved for this, we just say to ourselves, 1.924 times 10 to the negative 22nd is equal to x over 6.022 times 10 to the 23rd. I got x to be 115.9. So it's probably indium, right? Especially if these are experimental data. That's what I got. Did you get something similar? 115.9. All right, how do we feel about this one? How do we feel about these problems as a whole? Any questions on unit cell calculations? All right, that's where we're going to stop for today then.